guys, so we looked at discretionary and essential expenses, and then we looked at mean, median, and mode, and then we looked at some sigma notation problems for summations. So now we're going to look at some application problems for these different kinds of things. So looking straight into example 1. Elena knows that her morning cup of coffee is most definitely a discretionary expense, so it's not something she has to buy. She pays $2.75 for a 9-ounce cup and was wondering if that's a typical price. On Monday, she asked 6 of her coworkers what they paid for a 9-ounce cup of coffee. Their answers were $2.85, $2.15, $1.95, $3, $2.05, and $2.40. How could Elena compare her expense with those of her coworkers, and how does the price of her cup of coffee compare? So I'm going to go ahead and just say that she could use the mean. If she figures out the average of her coworkers' cups of coffee, the price for them, then she could then determine how hers lies in line with those. So in order to find the mean, we're going to add all of these answers together, or the prices together. So we have $2.85, $2.15, $1.95, $3, $2.05, and $2.40. And then we have to divide all of that whole sum by however many answers we have, and we have 6 because we asked 6 people, as we said. And if we actually figure that out, since we are looking at numbers that are dealing with money, we're going to go ahead and use it as decimal, and we're going to get $2.40 for the average. So the average price her coworkers actually paid for a cup of coffee was $2.40. Elena's coffee is 35 cents, oops, I wrote 35 cents more expensive than that. So that's how it lies with those. So hers was above average, so she could try and find a way to lower that. So sometimes when we do use sigma notation, we're simply adding up a list of things instead of using an expression. So like before, we would use like a squared plus a or just I. But that's not always the case. We're just adding up a list of different things. So when we use this, we're going to use a variable with a subscript. So like if we have a as the variable, we could have a little number 3 down here. That's considered a subscript because it's below the number and tiny. So we use the variable with a subscript in order to label each thing that we're adding together. So, for example, if we wanted to find the sum of the test scores in the chart below, we could write it using the sigma notation in the following way. So we'd start out having to label them. Let's say x1, x2, x3, x4, x5, x6, and x7. So now that we have that x1 is 88, x2 is 95, x3 is 97, x4 is 32, x5 is 99, and x6 is 87, and x7 here is 74. We could write this in a different way. So we would have a sigma still, because we are doing a sum, and then we would use x sub I, because the thing we're changing here is the subscript, and we would take the subscripts from 1 here is the lowest, and we're going all the way up to the 7th number. And so this would be the same thing as saying x1. We just replace the x, or the I, each time with numbers from 1 to 7. So x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7. And so that's how that would actually be written out. But we would write the sigma notation this way. But then if we actually replace these, x1 we said was 88, x2 we said was 95, x3 we said was 97, x4 we said was 32, x5 we said was 99, x6 we said was 87, and then x7 we said was 74. And if we actually added all these together, we get 485. So we're going to have to use that down here. So if we wanted to find the average of test scores, we could simply take this sum and we could divide it by the number of test scores recorded. So here, we could write it as this summation. That's an ugly sigma, but that's okay. And we could just divide it by the number of test scores, so divided by 7. But instead of writing it that way, I'm going to write this divided by 7 as 1 over 7 times this summation, because it's the same thing. Okay? So that's usually how you're going to be seeing it, if you see it out there. That's just the average. That's saying we're adding every value from 1 to 7, all 7 values, and then we're dividing by 7 because we're dividing by the number of scores that we have. So if we actually took this, 1 divided by 7, then we're multiplying it times the summation, which we set up here was equal to 485. And then if we took this 485 and divided it by 7, I'm going to round it to the nearest whole number since it is a score, and we're going to say that it gives us about 69% as an average. So, again, you're going to probably see them this way. You just use the variable with the little subscript I down here and the little subscript numbers, and that just labels which thing we're actually looking at. So if we look at example 2, if we use the information example 1 about the coffee prices to represent the formula for the mean price, then it is telling us, represent the formula for the mean price using a compact notation, and that just means a sigma notation. Compact just means it's shorter. So if we label these x1 through x6, our coffee prices, since we have 6 of them, then we could say 285 was x1, 215 was x2, 195 was x2, $3 was x4, 205 was x5, and 240 was x6. And then from there, the sigma notation, we're going from x1 to x6. So we have to start that at 1 and we go all the way to 6. Okay, and so this is showing that you add up all of the xi, each x1, x2, x3, x4, all the way through x6. And then in order to find the mean, we have to make sure we divide by the number of prices we have. And so we just multiply by 1 over 6 because that's the same thing as dividing by 6. And so this is the way we would write that in sigma notation after we've labeled them using this method. Let's look at example 3. Anthony wants to make a discretionary purchase of a basic laptop. He checks the prices of a particular make and model listed by 7 different websites. He found these prices: $850, $789, $2,400, $790, $836, $700, and $780. He computes the mean as $1,022. This number doesn't seem to be a good representation of the data, though. Anthony found what's called an outlier, a piece of data that's extremely different from the rest of the data. When there are outliers, our mean is often not a good representation, like how if you have 1, 0, even though you have all other good grades in a class, that can bring your grade down tremendously. Since the mean didn't work out in this case, how could he find a number that would better represent the data? He could probably use the median. So whenever you have an outlier and you have skewed data like that, that's what it's called. When this data is messed up by outliers, it's called skewed data. And then they need to use the median because it's not affected by outliers. So if I list out the numbers here, 700, 780, 790, 798, 836, 850, and 2400. In order to look at the median, we're going to mark out the ones on the outside one at a time in pairs. Okay, and that would give us 798. So 798 is the median. And since the outliers are either going to be on the far right side or the far left side. So like -3 would be 1, and then 9,000 would be 1. They'd always be marked off first. So because of that, the median is really good to use to represent data if you have an outlier. Now we'll look at example 4. So it says, transportation expenses to and from work are considered essential expenses. Declan would like to reduce this essential expense by biking to work rather than taking his car. He found 30 different ads, both online and in print, for the make and model of a bicycle that he would like to purchase. He made a list of the prices in ascending order. So from biggest to smallest to largest. Okay, and here it is. He wants to analyze the prices, but he's having trouble because there's so many numbers. So he decides to write a frequency chart, or frequency distribution, sorry. So if you look at a frequency distribution, it's a table that displays each value and its frequency, or the number of times that the value appears in the data. The table has one column listing the prices and one column listing the frequency. Make an example of what this table might look like. And then also we've added a column for the product, or the multiplication of the price and the frequency, to make it easier to find the mean later. So if we look at those numbers and we try to put them in this chart, we have 250, okay, and that's on the list twice. We have 275, and that's on the list 4 times. We have 280, and that's on the list once. We have 290, and that is on the list twice. We have 310, that's on the list 5 times. 315 is on the list 6 times. 320 is on the list once. 325 is on the list 3 times. 335 is on the list once. 330 is on the list once. 335 is also on the list once. 340 is on the list once. And then 350 is on the list 3 times. And if you add it all up, that gives us 30. And that just kind of, that total helps you to make sure that you have all the data listed, since we do have that he found 30 different prices. And if we multiply 250 times 2, we're going to get 500, and so that's how we're going to do it. We're going to do 270 times 5 times 4, and we're going to fill in the rest of this chart like that. If we added all these together, we get 9250, because each one of these is just the price for each bike. This is going to be the price for all of the bikes added together, and so that's going to be our sum if we added them all together, and then we're just going to divide by the number of bikes we have. So the number of prices we have is 30. That's going to give us about $308.33, and that's going to be the average price for the bike that Declan chose for the prices that he found. And again, we rounded this because it is dealing with money. So if you guys have any questions, let me know. I want you guys tomorrow to work on the practice problems that are similar to these. Let me know if you have any issues, if you have any questions. Thank you guys for watching, and have a great day. Bye.